welcome to the session with Matthias Niehoff. So, hello, Matthias.
Hi, everybody.
Good morning. It's great that you join us today. Matthias, you work as head of data and AI and data architect for CodeCentric and support customers in the design and implementation of data architectures. We are really looking forward to a promising talk, and I hope everyone will enjoy it. So thank you, and the stage is yours.
Yeah, thanks for the introduction. Yeah, Matthias, my name. I will talk about data architectures today. I think an important and an increasingly important topic by now. And if everybody just talks about architecture, it's often about software architecture, and I guess data architecture is an essential part by now. So when we talk about data architecture, what is it all about? So a really general introduction and a short general introduction. So we're talking about system and processes to store and provide and analyze data. And we want to do it to do data-driven decision-making on a strategic level, or to provide data-driven use cases and products, so more on the operational level. And of course, everybody's talking about LLMs and Gen AI. I'm pretty sure that if you want to use it for yourself and for your company and really have an leverage on it, you have to have your own data ready for use. But when handling this, there are a lot of challenges that occur at this time. So two of them are, the one is data is distributed among different entities, applications, units, whatever. So it's not like data is at some point, but you gather data on all levels and on all hierarchy level, on all business units, not only in tech and IT, but also on the business side. And it's therefore pretty hard to manage. And it's a topic for decades, and it's getting more and more important because of the reasons above. We're getting data-driven most of the time. So, and I'm doing this is going to be a rush, I guess, quite a ride for this, for the 40 minutes, roughly. So how it started with all the data stuff. And the first thing we did years ago, I guess it started in the 60s, all these data warehouse stuff. We have structured data in some databases, doing some ETL processes, storing the data in data warehouse and doing BI and reports on it. So still pretty common and not wrong at all, but just a pattern that emerged pretty early. It is pretty widespread. Then there came the data lakes, which had there was a thing like, okay, just put all the data in the data lake, not only structured, but also unstructured, semi-structured data. We have some ETL processes working on the data lake and process there and do something there, or they fill a data warehouse where you still get BI and reports, but you can also do all this data science, machine learning, or AI stuff on the data that is stored in the data lake. And also here, we have some key components, central key components. I'm coming to the central later on. Then in the last years, also cloud data warehouses gained further further widespread in the industry. So beginning with Amazon Redshift, which is one of the early ones, together with BigQuery. I would say BigQuery is far more interesting because it's serverless actually, and in the last years, especially Snowflake gained in popularity. So we're doing the data warehouse stuff, but in a cloud. So we're getting, it's easier, scalable. It's not a huge upfront investments. The old data warehouses were more like, okay, I'm buying a data warehouse somewhere. I'm buying servers for it, mostly specialized servers. I'm really have to pay a lot for licenses. And now it's like just more like a pay as you go and pay as you grow way of using data warehouses in the cloud. So by now, I would say every company that is using cloud, a lot of them we're seeing going towards cloud data warehouses. And together with those cloud data warehouses, there was another change in things. I was talking about ETL before, and it's increasingly becoming ELT. And one might think, hey, I mean, this change in the order of characters, what might even change. I mean, ETL was really like, okay, I'm extracting the data from source system, I'm doing some transformations, and I'm loading it into the database where I do the analytics and show dashboards on it. And this change to, okay, I really focus on the extract and load. I don't do any transformation on it. I don't do any business logic in it, because that is what most of the time happens. It gets entangled all the time. So really just getting the data from the source system, putting it into the final system, which is a cloud data warehouse, for example, and doing all the transformations on these cloud data warehouse. This is way easier to think about, to reason about. It also gives you a kind of a performance advantage most of the time, because you're working on the data itself, not on the data in flight. So this pattern became increasingly common over the time. And it still is. It's just more like, okay, I just want to get the data into the analytical system. Don't do the transformation. Don't do any preparation for star schema or whatever in between. Just get the data in and do all the transformation on this then. And with this, then there came the data lakehouse, which is kind of marketing from Databricks, because they have the data lake most of the time, but you can do SQL on it and can do SQL in a way that feels like data warehouse-ish. So you don't even have to think about, okay, it's stored in files. You don't care about it. So they came up with a data lakehouse, and we're getting a lot of new storage formats. So if you're storing data, you might store it in a database, but if you store it in a files-like system or blob system, you're getting over to formats like Data Lake, Iceberg, or Apache Hudi. And there's always quite some discussion who is the better one, who is the one with the better features, better integrations. They also coming with stuff like asset transactions on those data, and so commit logs. So it's getting pretty sophisticated, and it made it easier to actually just store to actually use data stored in file systems in a way with SQL that feels like a data warehouse. So, but for all of this, the one challenge was centralization. So centralization is a good thing, because you have control, you have in quite easy management, you can have quite a good cost overview, because you have one central data warehouse, if it's in the cloud or not, or one central data lake, and you can manage the access to this data lake and all the governance stuff in a central way. And this is typically done by a separate team, the data warehouse team or the data lake team. And as well, more and more data producers and consumers coming up, wanting to put data into it or getting data out of it. But they never actually talked with each other, those providers and the consumers. They always talked with the data team. And the data team was most of the time a good technical team, but they didn't know the data by content. So they were not domain experts of the data. And then a lot of things get lost in translation, and in the end, they become a bottleneck most of the time. And this was the main motivation for a concept called data mesh. I'm pretty sure, everybody who has heard about or thinks about data architectures came across data mesh in the recent years. So I'm keeping this brief. We have 4 principles here. Domain ownership, the one that owns the data, owns the domain, knows the data, also owns the data provided for analytical purposes. These providing is not just, okay, here it's in SQL access, you can have it, or here's an CSV file and ready to go. It's really like thinking data as a product, not only as an asset, with all these things like I want to do contracts, maybe even I have to do thinking about what are my consumers, what are they needing, what will I break when I do changes, manage those stuff as well. So that not every domain has to do its own infrastructure. We kind of have the idea of a self-serve data platform where every domain just can offer their data and also use the data from other domains. And so that it doesn't end in total chaos, we have this federated governance stuff, which means like, okay, we all together getting a kind of governance in an automated fashion. Most of the time it's federated automated governance that ensures that certain standards are applied. Just a short overview, how does they play along each other? So we want to use data as a product to prevent silos. So really like offering our data as a product, as something valuable for others. We enable the teams using the self-service data platform to actually have the domain ownership and live it. So that we reduce the cost by using the self-service data platform, providing, maybe even by a central team, so teams can provide data as a product. We increase the exchange by having standards between the domain ownership and to connect data. And the central guidelines also fly into the self-service data platform where they are implemented and maybe even enforced. So this is the general idea of data mesh. It's not a data mesh talk. I would have, there are plenty of them outside, I guess. My summary on opinionated summary definitely on data mesh, it's obviously more organization and technology. It's not something like you can install with a product. I guess that's known by now. But it's a good thing for discussion, I guess. The concept in it are proven. I mean, domain ownership, domain-driven design. You have these ideas maybe from software engineering and software architecture as well. It's a good toolbox for data-driven companies, and this is what we feel like. It's not like, okay, we're going to introduce data mesh, or customers coming, hey, we want to introduce data mesh, but it's ideas that you have that you might apply in your organization. And I would disagree with the ones from ThoughtWorks that they, hey, okay, you should focus on all those 4 principles and not just start with one. In my opinion, the first 2 principles, especially the data as a product principle, is already pretty valuable, because it actually says, okay, data is not, or analytical data is not just something that is a byproduct of building a web application or some application, but it's something that is valuable, that is a first-class citizen, that needs attention, that needs to be managed, and that has value in it, especially if combined with other data. And I think all this stuff is a good thing out of data mesh, besides all the hype that is coming along with it. So I already mentioned software engineering here is, okay, there might be influences of DDD, and the influence of software engineering in data is getting bigger and bigger. I mean, I was working in an insurance company a few years ago, and it was like, okay, we're doing the software and the architecture part, and there's this old dirty team that does the data warehouse stuff, and we actually don't get too close to them. That's some pretty magic. They have some software that nobody understands, but it's getting different by now. So software engineering gets influence, and all the practices software engineering gets influence into data in the data analytics and data architecture part. I mean, there is the software part for a long time. I mean, we have to talk about Python when talking about analytical data architectures. We have all the Python tool stack, and yeah, we have also R and MATLAB and Julia and all this stuff, and also Kotlin has now data frame APIs, but in the end, it's Python ecosystem everywhere, and everyone can do Python most of the time. But Python, I mean, yeah, Python is a programming language, but I just given a talk, that's a German slide, but how much software engineering should a data scientist can do? And my opinion, so coding is not the problem for data scientists, but building software is not in their heart. But it's getting more and more important to actually build software. It's not their job to build software. I mean, as a data scientist, you're hopefully somewhere in the connection between the business and domain and the data part, and not like, okay, I have to run Kubernetes, but it's getting serious. So it's not like, okay, I'm doing some analytics and hey, I maybe build some Excel reports or create some graphs, which I just copy and paste into a presentation and then send some management. I mean, we are building software now. We are building production-ready software, and then you're coming across like things like Kubernetes, because hey, you say you want to deploy something. Yeah, we deploy everything on Kubernetes, and the data department is like, Kuba what? Maybe they heard of Docker, but Kubernetes. Or on the other part is they coming with the fully fledged Databricks solution, and Databricks is a pretty big platform where you can do a lot of stuff, and you can do it, and it takes serious effort to do it in an engineering stuff way that doesn't get too cumbersome. I mean, you couldn't do everything in notebooks, but you can also do it in a more structured way. So the influence of software engineering and the importance of software engineering best practices getting more and more in the data part, in data architectures part. And on the same side, data architectures has some own challenges where you cannot just say, yeah, just do it like with the software architecture part. And what emerged from this is the so-called modern data stack. Also, if you Google modern data stack, you will find plenty of definitions and plenty of vendors selling their solution as the modern data stack. But basically, it's DevOps applied to data for me. So you run the whole solution of data, of storing and analyzing and providing value with data as a team. And it combines also the tools and processes to prepare and analyze data. It's often SaaS solutions. It's often the cloud data warehouse in the center. It's cloud technology on a technical scale. And you have all these, what commonly refers to as DevOps, the automation, optimization stuff, the infrastructure as code stuff, the CI/CD stuff, this testing stuff. And all this stuff comes and gets into the data stack by now and into data architectures. And you get software engineering best practices. I mean, some people of you might have seen that people who just want to do some data analytics, they either write those Python scripts where they basically write SQL and then execute this and get a pandas data frame, or on the right corner, we have like a Jupyter notebook in this case to actually do data. So this is what is done oftentimes, but what emerged then is also like tooling around it to actually do data these automation and CI/CD stuff and all this stuff also on your data warehouse. And having the software engineering back practices, if feasible, transferred to data architectures and data implementations. One of the pretty famous tools here is dbt, which does the T in ELT, so it doesn't extract, it doesn't load, but it does all the transformations when you are in a data warehouse, in a data platform. You see down there, you have supported all the popular ones like RDS and Snowflake, but also like things like Postgres and also Databricks, for example. So you actually have a layer on this. And you can do, here we've seen it, CI and CD and diffs on this. So in this case, this is something like, okay, hey, I want to merge this branch, and it gives me an update about, hey, how would the data change in this case if I merge this branch? How would the data, how many rows would be deleted? What would the distribution of the values? So you can see all this stuff directly in a merge request. Unthinkable of years before. So we're getting software engineering back practices here. We're doing we're monitoring. Here we have tests as well. So monitoring, tests, we have writing tests about data. Is the data in the expected format? Is it the data in not only format, but also is the content in an expected way? Is the values in an expected range, and all this stuff is done as well. So also testing gets into data architectures and data engineering. And we have those stuff like formatters and pre-commit and all this stuff. So actually really doing the data stuff. So that was the dive into, okay, influence of software engineering. But the main part is also we have to get the data somewhere. And this is mostly software and oftentimes written software. And consistently providing data is not within the competence and most of the time not in the priority of a domain team. I mean, a team that works on building an application and gets all the requirements from a user perspective. This application should do this and this and this, and then somebody comes and say, hey, we want to get some metrics out of it, and we want to see what happens with these application, or hey, we want to use your data for training a machine learning model because we might add some new features in the application. And this is one like, oh yeah, here's the dump, or here's the here's a database access here. You can just use it. There's a SQL user with a view. You can access that. And this is the typical patterns then that emerge if data is provided for analytical purposes. And it's sometimes totally okay. Sometimes it's more like the lazy part. Sometimes there's even an RP that entangles the actual database schema from providing data to others. And often we see, we just publish events on Kafka anyway, just get the events there and then you're done and you have all your data you need. And to be honest, I've seen this multiple times, and I've seen multiple times the data teams fail. And I wouldn't blame the data teams for it. So the data team. Because, I mean, publishing events to Kafka it's powerful. You can build histories. You get all the information you need, but it adds some burden because the data team is often interested into a state, maybe in a snapshotted state, but it's a state. So what was the values of our accounts today, yesterday, the day before, and so on. They don't want to use events and build the state yourself. I mean, this is domain logic that they actually might not even know or have to re-implement. So in my opinion, the batch, and often it's more than enough to do the batch way, to do the really simple and easy to use integrations instead of using these really powerful and I would say sometimes over-engineered solutions that came across from the software architecture world. And this is where the software architecture world is, and the ideas of software architecture world are maybe a little bit too much for the data world. So I would argue to provide simple to use APIs that might be tables, files, maybe REST APIs, something well-defined API, and provide means to get a state. What is the actual state of the data I'm interested in, not only the events? And this might also be like, okay, get me the complete state, or give me only a diff which changed in the last day or whatever, but it's always a state I get. And one thing that emerged in the last months, maybe years, I think there's like 12 different specs now for an API. So we have spec for APIs, Open API and Co. So we also want to have specs for data. And there's this thing like data contract. And there, as I said, a lot of specs for designing a data contract. Now, this is from InnoQ started one contract. This is the image from them, but there's several others as well. And the data contract, for me, it's not about the contract in this, because it's formalized and written in some YAML most of the time. It can also be technically enforced. But the main thing of this contract is people are aware of they providing data for analytical purposes to consumers they weren't aware of before, maybe. And they discuss what changes might be, what is actually needed. So it's basically an instrument to talk with each other. I mean, that's the hard part as always, to talk with each other about interfaces. And you write it down in a contract, and you have something to talk about. You have something to discuss, to actually say, hey, could we change this? But when we would change this field or add this field, what would this mean for you? And I've seen implementations that data contracts are that you don't do a contract for forever, but okay, we agree on this contract for the next year, and we are re-evaluate in 1 year, and let's see what do we have to change, or maybe the producer wants to change something, or the consumer wants to change something. So this is an idea that recently came up. A few startups also in this context that get some funding for building platforms to manage data contracts and all this stuff. Guess this is something we will see further when doing these pretty hard to solve thing between applications generating data and the data analytics architectures using the data. And this is not only the one way. I mean, we also have the way in the other way around. So statistics reports should be shown in the application again. We doing ML predictions or ML models, they should be shown in the application again. So in an online application, in customer facing or whatever user facing application. So it's not like, okay, not like the analytics platform only getting data, but they're also providing things on the other side. So in the end, one could argue that say, hey, teams must now be DevSec, FinBiz, DataOps, and all this stuff. DevOps is not enough anymore. I tend to say that's not going to work. But if at least the ideas that, hey, analytical data is of purpose, is of value, it's worth investing it, it's worth managing it, and it's worth discussing about it and sharing it. I guess if this comes out a few times, and more than before, that would already be of great value. So what is typical situation when we see people architecting for data or thinking about data analytics architectures? The one thing is, we finally want to use our data more for we have some applications, some self-developed, some standard software. We do some basic reporting, but most of the time we just dump everything to Excel and let the business figure it out it's safe. Or maybe we have Power BI because they can do fancy charts on the Excel data then. But we want to do it in a structured, automated way, in a more easier, accessible way. I would say what to do now is focus on the basics. I come to the basics and use simple but structured solutions. So have those software engineering best practices in mind, but don't go over the top. And the basics are the automation and structure. It's most likely some thing in the cloud. We have good things about the using a DVH or even just a Postgres database as a start, and you will likely start centralized. You don't forget about all the data mesh stuff for now. You will likely start centralized. But the main basic is this data culture and data thinking stuff you have to work on. So the people have to understand, the folks in your company have to understand that data is just not an asset, but something valuable that can be used outside of the applications. This is mostly on the IT related stuff, but also teach the company the business value of good data. What is it worth if data isn't just typed in a free form with whatever format and whatever mood of the day I was, but what is it worth if it's in a structured way? And therefore, we have a podcast on our website with Boris Adrian from Merck, who tells the story about they doing actually workshops with people from business, the total non-technical. They're telling some basic things about SQL and giving them clean data and unstructured data, and the people understand, hey, I know the challenges now. But they also do some things with them and say, hey, what we can do with this is, for instance, this. And then the people start, okay, when we have this data in a good format and have this data as well, we could do this. That sounds great. Let's invest in data. So really make the things tangible for people in the company, also outside the tech region. The other part is we want to do more. We have a large IT, a lot of self-built systems. We have already existing DBA, BI solution. We have a data lake. We dumped millions of dollars or euros in Hadoop, and we want to do more. So still work on the basics. So I think the data literacy stuff and so is important here as well. But here, if you start to scale, you maybe think about decentralizing. You think about other team structures, organizations. You're thinking about how to do standards and governance. And you might think about more powerful platforms, not only cloud DBRs. You want to do all the machine learning stuff and Python and all these stuff. And DBH is mostly SQL. Snowflake has also Python engines, yeah. But you want to have maybe more powerful platforms. And I guess this is not too new, team topologies. And this applies also to the data stuff. So having stream-aligned teams working, creating the data, and how the data fit in here. So we have enabling teams helping people providing data. We have a platform team maybe providing the platform for actually doing so, for providing the data, for easy means. Don't have to get into Python and Parquet and all this stuff, but I can just say, hey, I want to publish this data and nearly done. We have complicated subsystem teams. Maybe it's the data analytics stuff. Maybe it's also a streamlined team. So I think the ideas of team topologies also help you on the data side on how to structure and organize the things there. There's a blog post also, the second one, the future of data science teams, a few 2-3 years older, but I guess gets some glimpse of how to merge team topologies and all this data stuff, and some pretty good ideas, I guess. And in the end, you come to the question, okay, centralization versus decentralization. Should it be really a central team to do this, to care about data for analytical purposes? So software development gets decentralized. We have this DDD microservices, we have stream-aligned teams and all this stuff. And I'm pretty sure that this will happen with data as well. But data isn't meaningful or valuable just in a decentralized, separated place. You have to combine it with other domains. And this is easiest done and managed in a centralized fashion. So I would say if centralization works for you and you don't have any pain and you don't feel like you're going slow or the central team becomes a bottleneck, I would say, hey, centralization is always easier. But if it becomes a bottleneck, start to distribute and work, especially on the governance part. So the federated governance part that is also introduced with the data mesh ideas is really important then. Because building a platform, okay, but getting all these people work together, agreeing on standards, on agreeing on and enforcing also regulations, maybe in a decentralized fashion, this is the hard part then. So, and last, what can a basic modern data infrastructure and architecture look like if we start now, if we want to say, hey, let's invest in it? The one part is the cloud data warehouse. For me, quite lean approach. You have some storage and processing. You basically put the burden into the data warehouse of processing the data. It might be Google BigQuery, it might be Snowflake, it might be, which are really like the data warehouses. But we have a lot of, especially a little bit smaller clients, starting just with the database. Might be hosted in Amazon ADIs, might be an on-prem Postgres, whatever. Then we have the integration part, which does the EL part, which is standard tools like Airbyte or Meltano, which there are 5 and there are multiple of them, or you write Python scripts that are doing this, or you're doing event data capture with CDC stuff, where you, I came across this, have to build at least the state on your own. Adds a little bit more burden to the processing and the transformation, but might also be a solution. And for the automation part in all this storage and processing, we see a lot of companies and people adopting dbt. Pretty common now. I've been to a data warehouse conference or data analytics conference in Germany, a major one, and there were like plenty of talks about dbt, about how they do it, how they integrate it, and not only consultants like me, but also a lot of actual customers and users doing this. So this is really just this technical storage, integration, automation part. In addition, there comes things like governance, and you want to have like catalogs and lineage, maybe. This comes in addition to this. The cloud platform itself, so that would be another solution, is the all-in part. Now I have the Databricks cloud platform in the upper right corner, or Azure Synapse in the lower right corner. You get everything. So you can build everything, you can do everything. You can also do it with some AWS or Google solution. And it's especially with Databricks, and because I know this from several projects, really easy to start. You can just start with your notebooks, and it makes you the head start is really, the barrier is really low at the beginning, but it's extremely complex and to integrate, to govern, to make sure it doesn't drown in tech debt and one-off solutions, but it gets in a structured way, and you really have to invest in it with people building this platform. You really need a capable platform team owning this platform and enabling the users to work on this in a structured and long-lasting way. And last but not least, I already talked about a data mesh is a socio-technical, but mostly organizational thing. And a tech platform for this, which is really tailored to data mesh, isn't existing right now. So most of the time, the existing stuff can be used for this. You can use things from the modern data stack, but this is more like the centralization part. Modern data stacks, this cloud data warehouse is always, and dbt is more like centralizing ideas. And if it's come to distribute, the easy way for engineers to share analytical data, for domain teams to share analytical data. Besides you just have to write to S3 and do it in Parquet and all the stuff, and we're doing this, but in a really easy way, which is, I'm a TypeScript developer building serverless applications. I don't want to get into Parquet, and there's no need to it. And there's things still missing, and but I'm pretty sure solutions will arise there in the next months, maybe 1-2 years, that actually focus on this part way more. Okay, takeaways after this fast ride. So wide range solutions for data architectures, cloud data warehouses to data mesh. We have lakes, we have platforms and all the stuff. depends a lot on the size and the complexity of the organization. Also, where are you in the data journey? We see that centralization is decreasing. It's not like we have the data warehouse team anymore or the data lake team, and they are the ones that are responsible for everything related data analytics. These software engineering influence is increasing into modern data stacks, and also the boundaries between analytical and operational works are becoming blurred. So it's more like, okay, it's not like, okay, we just give it them and then they do something about it. It's really like, and working together also on solutions, on products. And this will be interesting to see what roles this brings up, what kind of organization forms and team forms will come up here. But I guess there's no way back for this. Then, thank you for your time and stay with me during lunchtime. Really appreciate it. And I'm, of course, open for questions.
Thank you very much, Matthias, for this really interesting talk. Yes, we have some questions from the audience. The first one, is there a standard where a consumer can run an operation on the provider side that operates within strict boundary conditions? Like this data can only be returned in an aggregated fashion. Call it a consumer lambda running on the provider.
So I'm not sure if I got the question. Could you please repeat it once?
Okay. Is there a standard where a consumer can run an operation on the provider side that operates within strict boundary conditions?
Okay.
Like this data can only be returned in an aggregated fashion.
I wouldn't think so. I get the idea. You want to run code because you are the consumer. You want to get some data in some way, so you just run it on the producer side so that it's returned in the way you want to have it. So there's no standard for it. I mean, you can definitely build things like this. It's a little of the question is a bit who's responsible for providing the data. I mean, as a consumer, you could also say, I want this data in this form, in this contract. Let's try to arrange this, and the provider has to implement and provide it. The question is who's responsible for building this code, for running this, for actually monitoring it and having it running. But I don't know of any standard in this direction. No, sorry.
Okay. Yeah, another one, and also the last question, but it's also a bit longer. Domains often have Michael says it's more about not having access to all data from the provider, but the provider only disclosing what you need.
So this is definitely the case. So I would it's not like the provider should propose everything he has. He should talk with the consumers what is needed and agree on it. It's not like, hey, here's all the data, or even in opening the internal data model. Oh, God, no. So really like, okay, hey, what is what you needed? What can I give to you? And then on the providing side, actually implement it and also do the filtering and aggregation if needed, for instance, for data protection purposes. Of course, it's not like opening up everything I have.
Okay, thank you, Matthias. So the second question, domains often have required and specific access management, for example, because of compliance. Putting it in a centralized system to base business intelligence on makes it difficult to enforce this access management. What would be a good way to get the business intelligence benefit, but not lose the access management for compliance?
So in the end, you would several ways I could think of. The one thing is apply the access management on the data analytics side as well. I mean, this is databases, they have roles, they have access, you can put them into ID for authentication or something like this. So you can actually enforce the same things as well. So people can only read this data if they're allowed to, and therefore also only can use this in analytics and reports. And on the other side is the strict part would be okay, or create a central, an own solution just for this part and just for this domain, and maybe offering only data that is open for everybody, or everybody or for more people in another way. This is on a high level perspective, I would guess, ideas that I would have to solve this. But I mean, it's not like I put everything in a strict way out into a data lake or in a data platform or whatever how you implement it. It's more like on this side, there's authentication, author validation, and all the roles as well. It's not like if it's there, everybody can access this. You can do role management as well. So the governance side, the governance doesn't stop when exporting data. It continues on the data side as well.
Okay, great. Thank you very much, Matthias. There are no questions left, so I think we have reached the end of the session. Yeah, thanks again for your great talk, for joining us today, and yeah, please everyone give Matthias feedback at the end, and yeah, enjoy your break, and we will continue at 2 p.m.